And
Okay. Can you see
please
my
go ahead.
screen? Can you see the screen? Can you hear me?
Yes.
Okay. So yeah, thanks a lot, Ted. And yeah, I'm going to tell you about this observation of a binary asteroid. So, planets can have moons, asteroids can have moonlets. I think Norm just mentioned Didymos and Dimorphos. Um, it's still a bit unclear how many asteroids have moons, what fraction of them, and there are plenty to be discovered out there. So here's the few words about the equipment that I've used for this observation. It was all done with a very modest equipment, an 11-inch Schmidt-Cassegrain telescope. This one is equipped with the Hyperstar system, which gives me a very short focal length. The nice thing about that is that it gives me a large field of view, so I can get multiple comparison stars to get good light curves. I use a camera which is more widely used to take like pretty pictures than to do precise timing. So to get accurate timing, I use one of these ART's GPS flashers, and that was very kindly provided to me by John Moore. So thanks a lot for that. And all this I control remotely from home, so I can observe occultations, whether it's cold or hot, from the climate control comfort of my home. And in case any of you is thinking about building a little observatory for their telescope and you're hesitating, do not hesitate, do it. This is the best thing I've ever did. I just did it myself. I'm not very handy. So if I can do it, everyone can. And I'm happy to answer any questions you may have about how you can build very simple things on track like that. So the asteroid is 10424 Gaia. It's a main belt asteroid with an estimated diameter of 6.5 kilometers. My understanding is that these estimates come from the infrared magnitude, and you can pretty easily back calculate an estimated size from that. It was discovered in 1999 by a French survey with a telescope in the south of France. And it was named by Alain Maury, who was one of the leaders of the survey. Some of you may know Alain for other discoveries that he's made and for his space hubs in San Pedro de Atacama in Chile. So Alain named the asteroid for Boris Gaillard, who was one of the people involved with the survey, and he wrote the computer code used, some of the computer code used in the survey. So you can sense a very strong French connection here. Asteroid discovered by a French guy named for another French guy, and observed here by another French guy, but from Mississippi. And this was the configuration at the time of the occultation. We were pretty close to opposition, which turns out to be really convenient. A few more words about the circumstances of the occultation. The occulted star was magnitude just under 13, and the predicted magnitude drop was 5, so the asteroid was around magnitude 18 at the time. The max duration of 0.71 seconds, and from my location, the probability of occultation was just north of 75%. So that's one of these asteroids with still a relatively large incertitude in the orbit relative to the small size of the asteroid. And that was taking place in January of this year, around 6 a.m. Universal Time. So that was about midnight for me here in Mississippi. So this is where I observed from. You have the whole path of the occultation here. Unfortunately, I was the only observer registered for that. But again, the path was very narrow for such a small 6 kilometers asteroid. Here's one frame from the video recording with the target pointed here. As you can see, there's a fair amount of background noise. I had to crank up the gain quite a lot to make sure I could record something for fairly dim star. I use an exposure time of 90 milliseconds, And as a reminder, this is an 11-inch telescope that I use. Now here on this GIF, which is slowed down relative to the real time, you can see the time stamps here. You will see the target here in the middle. So it's on a loop, so you're going to see it again. The target disappears, comes back, and disappears again. And when I saw that, in real time, it was 3 or 4 times faster. So I was like, wait, did I just blink, or did it really happen? So I got really excited. I quickly processed the light curve through PyMovie and IOTA. And yes, I did not just dream it. There's really 2 big dips in the light curve, so 2 occultation events. This is just zoomed in around the event. And the total time of occultation sums to roughly what was predicted by Occult. So how do we interpret this? Well, it could be a binary asteroid, or maybe one with a really elongated shape. It could be a binary star. And I quickly eliminate the possibility that it's just scintillation because I had a pretty good signal-to-noise ratio. A cloud, a bird, or a plane that moves in front of the star, that can happen. But for this to happen right at the exact time, to within like half of a second, the exact time of the occultation, that seems really unlikely. So really what we need to do is tell apart these 2 possibilities, binary asteroid or binary star. And the way we can do that is, again, by looking more closely at the light curve. So if it's a binary asteroid, then you're going to have 100% of a star from the light, which is going to be blocked by each of the events. So both times you will have a magnitude drop of 5 magnitudes. If it's a binary star, then you're still going to have some light from one of the 2 stars that remains visible. So your light curve will look something like that if you had one component that's very bright and one that's dimmer. Well, when the asteroid is occulting the bright one, your light curve goes all the way down. And here in this part, that will be when the asteroid is occulting the dim component. Now, the worst case scenario here will be if both components are of equal brightness. And in this case, you will have equal dips in the light curve. And you could do the math. The magnitude drop will be 0.76. So the question is the magnitude drop that we observe here more like the 5 magnitude drops predicted, or the 0.76 that we will get for a binary star? And here I'm showing where the magnitude drop would have been for a binary star with 2 components of equal brightness. And we can see that the light curve goes much below that. Just to be on the safe side, because you never know how linear the response from the system is, I plotted the light curve from 2 other stars that were in the field of view that were visible in the video. And this one, which is roughly the magnitude you expect if we had a binary star, and this one, which is almost a whole magnitude dimmer. And we can see that our target goes way below that. Here's a zoom version. I'm going to skip that. So pretty clearly, we had just one star, and it was an occultation by either a binary asteroid or something with a very elongated shape and 2 different parts of the asteroid successively occulting the star. So to tell these 2 hypotheses apart, what I did is I got some help from Mathieu Conjat. So again, French connection here. And he very nicely observed the asteroid from Nice, where I think he has access to a 40 centimeters telescope. And he started doing nighttime measurements of the magnitude to get the light curve. I realized that I could, with my more modest telescope, also get some data. And we got data across a bunch of different nights. And Mathieu did all the data analysis and generated these light curves that show these very nice dips, which correspond to either eclipses or other mutual events, if there's transit or mutual occultations of the asteroid. So I also, contacted the people at IOTA, so Norm and John Moore, contacted some experienced IOTA members. Dave Gold and Dave Herald were very helpful. They contacted some of the professionals that study this type of things, and they analyzed the light curve, they looked at their own data, and confirmed that the data was better explained by a binary asteroid rather than an elongated shape. So we ended up publishing a CBET describing this. So at that point, I thought I was probably the luckiest observer, seeing this, especially from the comfort of home. Meanwhile, people like Roger were having trouble with weather while driving hundreds of kilometers. And then I realized that, we have quite a few other discoveries like that. So that's from an email that Dave Herald sent earlier this year, highlighting 3, including this one, observations of binary asteroids and the corresponding size of binary asteroids that have been discovered recently through occultations. So they're not so rare, and we can find them with these occultations. So in conclusion, I think you want to keep observing, especially if you see in the prediction feed of Occult Watcher some like small asteroids around 10 kilometers in size. This seems to be the population of asteroids that tends to frequently have a moon attached to it. And when you observe, you want to make sure you keep your signal to noise ratio pretty good so that you can detect a drop of magnitude and you can tell apart the difference between a magnitude drop of 0.71 or about 1 or something more, which will help you to tell apart between binary star and binary asteroid hypothesis. So that's it, and I think we're running a little bit late, so I'm gonna stop there. Thank you.
Well, thank you very much, Jean-Francois. That is exciting, and there you were on the absolute center line to do that discovery. One question, well, actually, I think I wanted to mention, I think the picture on your last slide was of Dinkinesh. That was the first target of the Lucy mission, and it was discovered to be binary by Lucy as an unexpected addition to their mission.
I think so. I will have to double check. I finished putting the slides together quickly this morning and just grabbed some illustration from Wikipedia. It might be, yeah, that looks.
It looked very much like it.
Yeah.
So I was going to ask the question, if the two components of a binary star were equal intensity, would that make it more difficult to distinguish between a binary star and a binary asteroid?
Yeah, that would be the worst case scenario, because the two dips in the light curve will be of equal depth. But as long as you can prove that the magnitude drop is more than what you will get for 2 stars of equal brightness, then you can tell these two things apart. So, and that's why you really want to have a good margin in your signal to noise ratio, because if you're just at the limit of detecting the target star and it completely disappears in the recording, you don't know if you had a magnitude drop of 0.5, 0.7, 1, 2, 10. So you need to have a good enough signal to tell that.
I see. Thank you.
Ed, I have a question. Hello?
Go ahead.
We have time, yeah.
I put a question in the chat about the Gaia Moons project.
I don't see the question in the chat.
That question is, are any comment about any contributions to the Gaia Moons project for double targets? Apparently not. That I wasn't aware of that project, but thank you for putting the link.
I mean, I know that.
Yes, I think it's very important because Gaia is detecting more and more suspected double asteroids.
I see.
Yeah, so there was a big release of data from Gaia recently. I think it's something like 500 more binary asteroids, if I remember correctly. Don't quote me on that. Which will be basically double the number of known binary asteroids. And I think there was some discussions about including this in a feed in Occult Watcher, like try to get a special feed of predictions for these ones. I don't know what the current status of that is, but it would be really cool to keep an eye on these ones.
Some of the events on Occult Watcher are marked with the Gaia Moons tag now. So those would be events to pay particular attention to if you're trying to detect a double asteroid.
I see. Thank you, Steve. Good to know. Okay, we're doing well on time. So let me turn it over to Steve Preston to talk about best and brightest asteroidal events of the coming year.
Okay.